We build these skyscrapers that practically scrape the clouds. We build bridges that leap across oceans. We're pretty incredible engineers. But how does all that genius really stack up against the raw, unpredictable power of our own planet? Today, we're going to dive into the incredible and sometimes kind of desperate ways we try to tame the Earth when it starts to shake. So let's just get right to the heart of it, right? Can we actually outsmart an earthquake? Is it possible to just stop a volcano in its tracks? When the ground itself turns against us, can our best laid plans really truly keep us safe? Well, the answers are way more complicated than you might think. All right, section one. So before we get into all the cool tech, we have to wrap our heads around one fundamental truth. We can't actually stop these things from happening. That's not what this is about. The real genius here is in finding a way to change the rules of the game. And here it is, the core idea. It's not about preventing the punch. It's about learning how to roll with it. The ground is gonna shake, that's a given. But we can fundamentally change how our cities, our homes, our lives experience that shaking. And that's a huge mental shift. Moving from just bracing for disaster to proactively engineering our way around the worst of its effects. So, where do you even start with a problem that big? Well, our first tool isn't going to be steel or concrete. Nope, it's way simpler than that, and it starts long before anyone even thinks about laying a foundation. It is all about smart planning. It's a concept called land use zoning. And I know, it sounds a little technical, maybe boring, but it's actually a profoundly simple and powerful idea. You just don't build your most important stuff in the most dangerous places. It's about taking a good hard look at a map and making life or death decisions about what goes where. And you can see exactly how it works here. In the high-risk zones, right up against a fault line, you put things that can bounce back easily. Think parks or farmland. But your absolutely critical infrastructure, your hospitals, your schools, your homes, you strategically place those on safer ground. Now, of course, this entire strategy is basically useless without two key things: incredibly accurate hazard maps to even know where the danger is, and, maybe most importantly, strong governance to make sure people actually follow the rules. Okay, so we figured out where to build. Now for the really cool part, how we build. And this brings us to our second tool, and this is where the engineering gets truly mind-bending. I'm talking about hazard-resistant design. This is where the whole philosophy of building just gets flipped on its head. Instead of trying to create these super rigid, unmoving structures that fight against the Earth, and let's be honest, usually lose, we design buildings that can move with it. The goal isn't to be unbreakable, it's to be flexible. It's to absorb and channel these incredible amounts of energy without falling apart. And one of the most brilliant technologies for this is something called base isolation. Seriously, think of it like a set of giant shock absorbers for a skyscraper. They sit between the building and its foundation, so when an earthquake hits, the ground and the foundation can be shaking like crazy. But these flexible bearings, often made of layers of rubber and steel, they just soak up all that energy. The result? The building itself kind of glides above the chaos, staying remarkably still. It's an incredible way to protect not just the building, but every single person inside. And the innovation just keeps going. Engineers have a whole bag of tricks. They're using these advanced flexible materials that let buildings sway like a tree in the wind instead of snapping. They anchor buildings with super deep foundations so they don't tip over in soft soil. And in volcanic areas, it can be something as simple as a steeply sloped roof, designed just to make sure that tons of heavy, wet ash slides right off instead of causing a collapse. Okay, so we've gone from smart planning to flexible buildings. Now for our third tool. This is where we stop being subtle. This is about scaling up, moving from individual buildings to massive brute force defenses that are designed to meet a natural hazard head-on. We're talking about engineering on a colossal scale here. We're talking about building a concrete wall to try and stop an ocean wave, or literally digging a new path to tell molten rock where it's allowed to go. This is humanity trying to draw a line in the sand and physically redirect nature's fury. And we see these kinds of massive defenses in action all over the world. Japan is famous for its huge system of coastal seawalls, built specifically to try and blunt the force of tsunamis. And near active volcanoes like Mount Etna, engineers have literally saved entire towns by digging channels and piling up earthen barriers to divert slow-moving lava flows. So these solutions sound pretty incredible, right? Almost foolproof. But now it's time for a pretty serious reality check. Because as powerful as our engineering is, we are definitely not all powerful. These strategies have very, very real limits. This right here is such a sobering reminder of our place in the world. Back in 2011, the Tohoku tsunami in Japan was just so immense, so much more powerful than anyone planned for, that it just flowed right over the country's massive seawalls, some of the most advanced on the planet. It was a tragic, heartbreaking lesson that sometimes nature just operates on a scale that is beyond our ability to engineer against. And then, of course, there's the money. The cost of this kind of protection skyrockets when you try to defend against the absolute most extreme events. I mean, building a wall for a 10-meter wave is one thing. Building one for a 30-meter wave could be 10 times the price. And that staggering financial reality means these mega projects are often only an option for the wealthiest nations. So when you start to add it all up, it's a really tough balancing act. You've got the immense cost, which just prices a lot of communities out. You have that constant risk that a truly extreme, off-the-charts events will just overwhelm your defenses anyway. You've got the environmental damage from all this massive construction. And finally, you have the purely human challenge of enforcing zoning laws in places that are growing faster than planners can possibly keep up. So at the end of the day, the biggest takeaway is this. There is no single silver bullet. True safety, true resilience, it doesn't come from one perfect wall or one earthquake-proof skyscraper. It comes from weaving all of these things together. Brilliant engineering, forward-thinking planning, and a deep, humble respect for the power we're trying to live alongside. Which leaves us with one last and really crucial question. If even our most brilliant engineering can't give us a 100% guarantee, what then? Where do we go from there? Because maybe the next step isn't just about building stronger walls, but about building stronger, more resilient communities through education, early warning systems, and just being prepared. Now that is something worth thinking about.